Thanks for watching my video today. Let's try to prove another limit, which is the easiest one. Okay, it is easy. Okay, so we just limit n tends to infinity 1 over n cube 1 plus 4 plus 9 plus and so on up to n square. Okay, so I'm going to prove this in two ways. Okay, first is using the integration. So let's say our limit to be L. Okay, L limit n tends to infinity 1 over n cube 1 plus 4 plus 9 plus and so on up to n square. Now let's put in terms of summation. Okay, limit n tends to infinity sum from n equal to r equal to 1 to n r square. Okay, r square, this one is r square. If you put 1, so 1 2 square 4, so 3 square 9 and n square, right? Upon this is n cube here, so we just limit n tends to infinity sum from r equal to 1 to n. Now 1 over n I'm taking out here, so you get n square, right, which is r by n whole square. Now from changing the limit to definite integral, you have to substitute this limit and this summation to be integration. Okay, integration, and this the limit of integration can be found here. Okay, r equal to 1 to n. So r by when r tends to 1, this one, so r by n will tends to 0. Why? R by n is nothing but 1 by n, right? Here we know that n is infinite, right? Meaning n is infinite, so when something divided by infinite, this will tends to 0. Okay, that's why 0. When r is equal to n, so r by n will be just 1. So that's why integral from 0 to 1. And replace r by n by x. Okay, so x square, so and 1 by n by dx. Okay, so this is easy, right? X cubed by 3, integral from 0 to 1, which is 1 by 3. Therefore limit n tends to infinity 1 over n cube 1 plus 4 plus 9 plus and so on up to n square is nothing but 1 by 3. Okay, this is the first proof. Now another proof, or we know that we have already proved the sum of the square of natural number. Okay, up to n terms, so which is 1 plus 4 plus 9 plus and so on to n square is nothing but 1 over 6 and n plus 1 to n plus 1. Okay, so our limit L is limit n tends to infinity 1 over n cube 1 plus 4 plus 9 plus and so on up to n square, which is limit n tends to infinity 1 over n cube. This part is nothing but this one, right? And n plus 1 to n plus 1 by 6. So limit n tends to infinity 1 over 6. Here if you take here n common here, so you get n cube by n cube, and here since we take n common here, so it will be 1 plus 1 over n, right? Here also 2 plus 1 over n, so which is these two can get cancelled. Now 1 by 6 is constant, so coming out, so 1 by 6 limit n tends to infinity 1 plus 1 over n 2 plus 1 over n, so this will be 1 over 6. Now distribute limit both of them, so limit n tends to infinity 1 plus 1 over n, limit n tends to infinity 2 plus 1 over n. So this will be when limit n tends to infinity 1 plus 1 over n, this is nothing but 1 plus 1 over infinity, right? And 1 over infinity will tends to 0, so which is just 1, so 1 into here, so 2 plus 1 over infinity, so 1 over infinity will tends to 0, so it will be this whole term will be 0, so 2 plus 0 is just 2, so this will be 2 by 6, this is 1 by 3, right? Therefore our limit n tends to infinity 1 over n cube 1 plus 4 plus 9 and so on up to n square is 1 by 3. Actually these two are same thing, right? The answer are same. You can approach in any way.